In this video, we're going to continue working some examples with the law of sines. In the last video, I did number one. So number one is already finished for us. I'm going to go ahead and grab my pen here. And I want to revisit, though, to start with our law of sines. So number one is already finished. And then for the law of sines, let me put this in black here, we put it together this way. So we have the sine, let me do it just a little bit smaller, that guy. Better. Okay, so we're going to do the sine of angle A over A. Its ratio is the same as the sine of angle B over side B, same as the ratio of sine of angle C over side C. It works for these two cases, angle, side angle in order, or side, side angle. I like to think of this one as the A word, ASS. One triangle construction for this one, and we're going to look at the two triangle constructions here. Okay, so like I said, we're already done with number one. So that one's finished from the previous video. Let's go ahead and get into number two. I'm going to start by just doing my best to draw the triangle so we can at least visualize it in part. Angle B is 50 degrees, so about 50 degrees would look something like this. So B is 50 degrees. A can be either of these two sides. I'm going to go ahead and let it be the lower side, doesn't matter, 108. And then side B right here, which is opposite angle B, is 49. So you can see that we've got, in order, our sequence, we have an angle followed by a side, followed by a side. So we do have the ASS case, which is two possible constructions. So we're going to keep that in mind as we're moving through. I cannot start with finding any missing angle measures. The measures that we are looking for are angle A, and I've got them labeled here, side C, and angle C. We're just going to dive in and use the law of sines to start. And as I use the law of sines, I grab given information. I need B's to go together, or A's to go together, or C's to go together. And I've got an angle B and a side B. So as I put this guy together, I'm going to go ahead and do the sine of B, which is 50, over side B, 49, is equal to, my only other given information is A. So I need to do the A ratio, sine A over side A, which is 108. I'm going to cross multiply. I'm isolating my angle A. So I'm going to need to cross multiply and then apply a sine inverse. I've got a little bit of work to do. Working through the math here, I end up with 108 times the sine of 50, all divided by 49, is equal to the sine of A. I'm going to go ahead and calculate this first. Make sure you're in degrees, and I am. So I just checked my mode and I am in degrees, so second quit. And let's go ahead and just type this in. So 108 times the sine of 50 divided by 49. Some red flags should go off right here. Let me write it down in red in case a red flag did not go off. We just came up with 1.688 and change being equal to the sine of some number. Sine can only be between 1 and -1. 1.688 is too big. This is not a possible triangle. It will not work. The triangle that I drew, right, is okay, but in reality, it means that I cannot connect. When I've got this 50-degree angle and 108 here, 50 degrees, and I've got this 49-degree length, 49 unit length, it cannot reach to the other side. So this is not a possible construction. So for our answer, I mean, there's a lot of things that you can just say does not exist would be one. So we're going to do that. DNE for does not exist. Does not exist. That makes me actually really happy because we don't have to do any more work. No possible triangle. Okay, next. These are not drawn to scale, obviously. It should be like more equilateral, but it's not. Here we want to find length x. So as I use my law of cosines, I have a side and its opposite angle. These go together in a ratio. And for the other two, I have a side and an opposite angle. Those are going to go together in a ratio. Oh, let's even color code these because why not? So we're going to do the sine of 42 degrees over its length x is equal to, and now let's go ahead and grab the other side and corresponding angle. So this is going to be the sine of 13 over 24. To solve this guy, I'm going to do some cross multiplying. So I get x times the sine of 13 is equal to 24 times the sine of 42. I don't do any calculations until the very end. I'm going to divide both sides by the sine of 13. So x equals this. Let's go ahead and put that into our calculator. So 24 sine of 42 divided by the sine of 13. And we get 71. So let me put it over here. So x is about 71.389 units. So there's our value of x. Okay, so another nice application. We don't need to solve the entire triangle. Okay, let's go on to number 4. So for number 4, we have an angle A. So I'm going to go ahead and just draw this best I can to start, and then determine if I've got one or two triangles based on the case I'm given. 107, that is an obtuse angle. Okay, so there's 107. So this is A. And then side A is going to be a cross. So I'm going to do that last. B is going to be one of these two, and it doesn't matter which one you pick. So I'm going to pick the lower one just because. So B is equal to 17. And then this side right here, we'll call that A now. And that's going to be 35. So my given information, I have an angle and a side and a side. So this is angle side side, which means I'm looking for two possible triangles. The values that I'm missing are C, angle B, and angle C. So I am missing angle B, which is going to be this guy, side C, and angle C. I have to start with the law of sines here. I cannot find an angle measure yet. So to start with the law of sines, I grab the information that's paired. So I'm going to grab a couple of A's, and then I grab the other piece of information, which is B. So let's go ahead and put this together, and we'll call this step 1. Okay, so for step 1, I'm going to do the law of sines with A. So sine of 107 over 35 is equal to the ratio for B. So it's going to be the sine of angle B divided by 17. Let's go ahead and do some cross multiplying. So I get 35 sine B is equal to 17 sine 107. Divide both sides by 35, and the sine of B is equal to 17 sine 107 divided by 35. Okay, let's go ahead and put that into our calculator. If we're lucky, this is going to be greater than 1 or less than -1. So 17, not 117. So I want 17 sine of 107 divided by 35. And it's a valid ratio. So I'm going to go ahead and apply a sine inverse. So B is equal to the sine inverse of that number 4, 6, 4, 4, 9, so on and so forth. So I'm going to do a sine inverse, and then I'm going to arrow up and grab that, or you can grab your answer from the negative key on the bottom, or you can do second answer. Don't round. These are all intermediate calculations. So this is one possible angle B. So one possible angle B, B sub 1 we'll call it, is 27 points. I'm just going to call that 7 degrees. There's a second one because I only got what sine inverse can give me, and that's this guy right here. This is B1. But I know that there's a second one, and that's going to be B2, which is this guy right here. So B2 is 180 minus that answer. So 180 minus, so you can see why we did all of that when we were learning how to solve the equations with the inverse functions. And I get 152, we'll use one decimal place, 0.3. So B2 is 152.3. So sine inverse gave me the acute angle. It cannot give me the obtuse, so I had to work for that one. So to find the obtuse angle, I just did 180 minus to get the obtuse angle. So that means that I have two different constructions. So let's do the acute construction. So to do the acute construction, we have angle B1 is 27.7 degrees. Continuing with the acute, we can do step 2, which is to find C1. So C1 is going to be 180, this is the angle, minus 27.7 minus 107. So we'll just do that. 180 minus 27.7 minus 107. Okay, and so this gives me C1 is 45.3. So let's go ahead and write these answers down in blue. So 27.7 will go here. 45.3 goes there. Okay, and then we want to do step number 3. We're still missing side C. So for side C, I'm going to go back to my given information and I'm going to pair it with the angle that I found and use another law of sines. So I'm going to do sine of 107 over A, so this is my A ratio, is equal to the C ratio. So the sine of 45.3 divided by side C. So if I do my cross multiplying and dividing, I have that C times sine of 107 is equal to 35 sine 45.3 all divided by, to get this one finished off, sine of 107. Feel free to check my math on that one. But I'm ready to go ahead and find side C now. So 35 times the sine of 45.3 divided by the sine of 107. Sine of 107. And we get 26.0 since I'm just using a single decimal place. So 26.0. Okay, so hopefully you wrote all of that down. If you are still writing, go ahead and pause. I'm going to actually erase the acute case, and then I'm going to go through and do the obtuse case. So if you're still writing, go ahead and pause, but I'm going to go ahead and erase all of this here. And then we'll go ahead and do the obtuse case. Okay, so now let's do the obtuse case. The obtuse case is with this guy. So with the obtuse case, B1 was 152.3. That was 180 minus the angle that we found with sine inverse, 27.7. Okay, so I've got my obtuse angle, and I'm going to go ahead and write all of these answers in red. So for the obtuse case, this would be like B sub 2 is 152.3. We can go ahead and start by finding angle C. So C sub 2 is 180 minus 152.3 minus angle A, which was 107. Interesting, right? Because that's not going to happen. If I tried to subtract all of those, I would not come up with a C2. So this obtuse case is not possible. Yay. I don't have to finish, but I could. I could have if it was possible. So I can cross this one off. Even though there were two possible cases, the obtuse angle was way too big. It was not going to work for a triangle. Let's go ahead and go on to the application here. So in this application, we are first looking for the distance from the helicopter to boat A. Let me clear my work here. So as we're looking for this, we've got over the red line, which is the river. So this is my river. We've got the helicopter here, which I don't know how to draw a helicopter, so I'm going to write H. And these are our boats. Boat and boat. To find the distance from the helicopter to boat A, we want to find this value right here. We can find some of these missing angles. So as I'm looking for these missing angles, this missing angle right here, first of all, is going to be, we're going to call this guy alpha. This missing angle is just going to be the rest of 180 degrees that makes up this rotation right here. So it's going to be 180 minus 28 minus 42. So if we do that, 180 minus 28 minus 42, we end up with 110 degrees. So angle alpha is 110 degrees. So we have this one. So now we've got A and the side opposites. We need another angle. The nice thing about these angles here is that we have what we call vertical angles. These are opposite angles. So this angle and this angle are the same. So these are both 42 degrees. So this is 42 degrees. And if I go ahead and grab another color, we've got vertical angles again here and here. So that one should be, where's yellow? So that one should be 28 degrees. So we have a lot of information now that will allow us to find this distance right here. So I've got X and its angle opposites, and I need another pair. I have this length and its angle opposite. So let's go ahead and put this into a law of sines. So for the law of sines, we're going to do the sine of a known angle. So let's do the 42 and the x. So the sine of 42 is to x as the sine of 110 is to 5.8. So we can do a little bit of cross multiplying here. So x times the sine of 110 is equal to 5.8 times the sine of 42. So x is 5.8 times the sine of 42 divided by the sine of 110. Okay, so 5.8, and I'm still in degrees, so I'm good to go. So 5.8 times the sine of 42 divided by the sine of 110. And we get that length, which is 4.13, and this is kilometers. So x is about 4.13 kilometers. Okay, next we want to find the elevation of the helicopter. That's going to be the height of this triangle. So if I redraw this, I want to pull out a right triangle. So I can redraw that one. I'm looking for that height. I know that this is 4.13. So let's go ahead and focus on this triangle right here. So I'm going to ignore the 5.8. That's not going to help me. I'm looking for the height. I do know that angle measure of the lower left angle, that's 28 degrees. So this is 28 degrees. So as I'm looking at this triangle that I have in yellow, I have opposite and I have hypotenuse. So opposite over hypotenuse is SOHCAHTOA, right? So that's going to be the sine of 28 degrees. So I can just use good old right triangle trig to solve this one. Let me do this in a different color so you can see. So I can write that the sine of 28 degrees is equal to opposite, which is what I'm looking for, divided by hypotenuse, which is 4.13. So if I cross multiply, 4.13 times the sine of 28 is equal to my height, or the elevation of my helicopter. So I want 4.13 times the sine of 28. And we get that height. So the elevation is 1.9. If I round that, we'll say 1.94 kilometers.